Hi everyone, this is Mr. Piri, and today we are going to look at Science Paper 1 from the year 2020 internal, and the topic is on the simple pendulum. So now there are some factors you're supposed to take note before we start answering this question, and the terminology which are used under simple pendulum, we have what we call oscillation, we also have what we call the period, and also the frequency. So let me try to describe what oscillation means. So oscillation, to oscillate simply means movement. Okay, so movement, in this case we will talk about the movement of this part which is called to be a bob. So the bob as it is swinging, we will say that is oscillation. But now we also have another term which is called to be the period of the pendulum. And the period of the pendulum, we are talking about the time. So period simply means time. So in this case, when you're talking about the period of the pendulum, we are talking about the time it will take for a bob to swing for it to make one complete oscillation. Then there's also called frequency, and frequency is described as the number of complete oscillations produced per second, like how many oscillations have been produced just in a second. And now the question states figure 2.1 below shows a simple pendulum suspended from a fixed point. So this is the simple pendulum itself, then this is the fixed position, and we have attached the string and also the bob is attached to it. Then the question says the bob is slightly pulled to position A. So the moment you hang it, it will be just hanging here, then you pull it this side. Then we are also saying that it's being released. Okay, so the moment you release it, which means it will start oscillating, like we have mentioned, it will start moving. Then now they are saying state one factor that does not affect the rate of period of the pendulum. So the things which won't affect the time it will take as it is swinging. So one of the things is the size. So for A is the mass of the bob. So the mass of the bob won't affect the time it will take as it is swinging. So it doesn't matter how heavy the bob is. Okay, so you find that it won't affect the time it will take, which is the period. The other part is the other factor. We also have the size of the bob. So which means it doesn't matter the shape of the bob, it won't affect the period of the pendulum. So these are the two factors that does not affect the period of the pendulum. Okay, so you can just mention one since they have said you just take one. Then for B, they are saying if the values of time for 20 oscillation, so oscillation like you have mentioned, so as it is making the 20 oscillation, then they are saying obtained where, okay, so the time which they have to obtain where is 16.1, 15.9, 16.0, 16.2, 15.8. Okay, then they are saying calculate the period of the pendulum. So for us to calculate the period of the pendulum, we say period equals to small letter t over n. So this capital letter T represents the period of the pendulum, then the small letter t represents the time taken, then the n represents the number of complete oscillation. Now if you are able to take note here, you have been given the value. So since it's an experiment, and in an experiment you do a lot of trials, so you can't expect the same value for the time it will take for the same 20 oscillation. You find that there will be difference. Okay, so in that case, for us to find the time, we are supposed to find what we call the average of the time taken. So how are we going to find the average? So the way we calculate average, we add this, and this one, then we divide with how many trials are there. So in this case, we are going to say 16.1 plus 15.9 plus 16.0 plus 16.2 plus, which is 15.8. Then now if you count, there are how many? 1, 2, 3, 4, 5. So we are going to divide the same number by 5. So in this case, if you add this, it will give us 80. Then 80 over the number, okay, which is 5, and if you divide, it will give us 16.0. So the value for time is that is for a small letter t, is 16.0 seconds. Then now we can able to calculate the period, where we say in this case the period will be equal, then the time it will be 16.0 seconds, then over the number of complete oscillation, they have said 20 from the question, so we'll divide 20. Then if you divide, it will give us 0.8 seconds, because period is also the time. Okay, so in this case, this is how you find the period or the pendulum. Then now the last question, they're saying calculate the frequency of the pendulum. So for you to calculate the frequency of the pendulum, you say there are two ways in which you can calculate the frequency of the pendulum. So the first one, you can say frequency, which is a small letter f, equals to 1 over period. Okay, so in this case, it's just it. You say 1 over the period. So in this case, we say frequency equals to 1. Then what is our capital letter T? So we won't get this 16, we'll get this 0.8, because that is it. There. That is the period. So in this case, if you divide, it will give us a number which is 1.25 hertz, because frequency is measured in hertz, which is Hz. Okay. If you don't use this one, you can just say frequency equals to number of oscillation over the time taken. So you just reciprocate the period. So in this case, you can say it's 20, okay, over this 16. I mean, in this case, if you divide, it will still give us 1.25 hertz. So this is how you answer this type of question, which is based on the simple pendulum. Thank you.